Hello, everybody, and welcome to our Planet Cassandra meetup. Today, we're gonna showcase a use case Apache Cassandra. We're gonna build a e-commerce website, and as Aaron just mentioned, it's a very common use case for distributed databases. So we have Aaron here, and the floor is yours.
Oh, well, thank you, Sohail. All right. Let me start by sharing my screen here. All right. All right. So, yeah, today we were going to hit on some real-world use cases for Apache Cassandra, and specifically looking at those use cases that come out of the e-commerce world. Um, and I should mention that when I first put this presentation together externally, I was on a little bit of a Cyberpunk 2077 kick, so that still remains kind of the theme of some of the slides here, but that's okay. Um, I was like I also mentioned to Doug, this started out as a workshop that we did at DataStax about building out an e-commerce site on top of Apache Cassandra. And the idea is that we would build out a new like backend service layer for each of these use cases on Cassandra as as kind of the weeks progressed. I think there's a total of 5 sessions, maybe it's 4. I forget, but essentially in this case, we're going to talk about like 4 use cases specifically, and then kind of dig into different aspects of each of those at a semi deep level to try and convey some understanding here. So that's that. All right. So why is e-commerce so important? Um, well, global e-commerce market size worldwide, yeah, estimated to be almost 26 trillion US dollars in 2023, and is projected to reach 83 trillion US dollars by 2030. So it's definitely, some place that needs Cassandra. It's growing. It's, going to grow by quite a bit since then, or, over that time. So, that's where a database like Cassandra really comes into play. So it can help out for some of those like larger scale use cases. And there are many like e-commerce enterprises that use Cassandra already today at a very large scale. Walmart is really big, for example. Walgreens, CVS, even Walmart and Target, and other you know like hardware retailers like Home Depot and Lowe's. Those are just some of the bigger implementations. But Cassandra, again, it's definitely one of those databases that helps you scale and kind of grows with your business as it starts to get big.
Hey, Aaron, two quick questions.
Sure,
One, is it okay to ask questions as we go?
sure, I'm okay with that.
Okay. And two, did you say that Home Depot and Lowe's are both using Cassandra?
That's right.
Okay, great. Thank you.
Yep. Anyway, so real quick, little about me. I'm a developer advocate at IBM, formerly at DataStax. IBM just bought us a couple of months ago, actually. I've written a few books, most notably Mastering Apache Cassandra 3.x. It's a little old now, but hey, it's still selling, so I'll take that. I'm a committer on the Apache Cassandra project, and I've been a engineer working with Cassandra at a lot of places over the last decade plus. I got my start with it at Granger. We were running on version 0.8 in production. I went to a startup and helped Acculinks build out their Cassandra cluster. And then I spent almost 6 years at Target as the NoSQL database engineering lead. When I first got to Target, we had about a dozen Cassandra clusters, maybe 100 nodes in production. And then today, they're at something like somewhere around 200 clusters well, not counting stores actually, and something like 11 or 12,000 Cassandra nodes in production. And if you add stores into the mix, that of course adds a three node cluster for all 1,850 stores that Target has. So, yep, definitely worked with Cassandra from my fair share.
And sorry, Aaron, one more question for you.
Sure.
If you're going to cover this, just let me know. So at those locations like Target, Lowe's, and Home Depot, are they using it for, the retail sales operation or for back end type work or a bunch of the different things?
It's a bunch of different things, but yes and yes.
Okay.
So yeah, no, good question. Good question. All right. So as far as the agenda goes today, we're going to talk a little bit about the architecture of the application and kind of how everything all fits in, and what we're going to show. We'll go a little bit into the specific use cases, actually four specific use cases, and then we'll take those use cases and talk about data models, building out some backend services on top of them. We'll touch a little bit on streaming. Um, yeah, I'll cover that eventually, but we will touch a little bit on streaming. I don't want to take the focus too much off of Cassandra and the e-commerce, use cases, but streaming plays into that as well. And then I have a demo where we can kind of put this all together. All right. So the tech stack, um, essentially, again, like I said, with the workshops that we were doing online, we were really building out a new use case, so like backend service layer for each use case, like every few weeks or so. And of course, we needed a website to kind of a website front end to kind of tie all this together and actually like show it in action. So we used Java Spring Boot to stand up the backend. And then we had some developers who were really good with like front end tech and really kind of helped us out getting us started with Tailwind CSS, and then building up a React.js, Node.js web front end on top of it. So essentially, the part that we're going to really focus on today is the services, and then a little bit on the back end as well. Fortunately, with Spring Boot, we also get Spring Data, and that actually takes a lot of the boilerplate, a lot of the legwork out of that back end, and I'll cover that as we go along. I mentioned streaming. Right around the time I joined DataStax, they bought a company named Kesk, and Kesk was a big streaming provider. They had a big presence in the Apache Pulsar community. There was a push at the time for us to show examples using Apache Pulsar. For those of you who haven't used it, it's an analog to Kafka, really. So if you're using Kafka, Pulsar is kind of what did we used to call it, like a data center aware drop-in for Kafka, if you wanted to go that route. But the idea is that I kind of use it later on to show like how you would process web orders through like their different stages of completion by having a topic for each one of those that the order would go on. But anyway, we won't go into that too much. All right, so for those of you who don't know, Apache Cassandra is a NoSQL. It's large scale distributed database. It's an Apache project. It's known for being able to scale linearly and support high amounts of read and write performance at scale. As far as like a CAP theorem sort of designation, it's what you'd call an HA database. So it's highly available, eventually consistent. That's how it's able to get such good performance numbers. The thing is that it's about a trade-off. Anything with large-scale database engineering involves trade-offs, and the trade-off that Cassandra makes there is that, hey, we can give you really fast reads at scale, but the replicas may not always be 100% up to date. And of course, there are ways to work through that as well. But that's the trade-off. That's the main gotcha with Cassandra. It's platform agnostic in the sense that you can run it on bare metal, you can run it in the cloud, you can run it on a VM. I've seen people run it on Raspberry Pis before. Not that you'd want to do that in prod, but you can. It's definitely possible. A lot of our customers actually run Cassandra out on Kubernetes these days, so that's certainly an option as well. And then, of course, the one thing that I feel Cassandra does better than any database on the market and has for a while is its geographically aware data distribution. Where you can configure logical data centers and have your data replicated around those data centers, and that's very useful for enterprises that may have customers on like the West Coast in the US, the East Coast in the US, and maybe they have some in the European Union as well. So maybe they build out 3 different data centers and they want that data to be available to all of those customers quickly and with great response times. And they use Cassandra to keep that data in sync. All right. So, kind of
Sorry,
the
Aaron,
impetus for this.
one
Oh,
more.
sure, Doug.
Sorry. And let me know if you want me to hold some of these questions until like a halfway point or something. I just wanted to know, is Cassandra in the same kind of category as Couch and MongoDBs?
It is in the sense that they're NoSQL databases. So with a NoSQL database, essentially what you're doing from like a cap theorem perspective is you're saying, hey, we want to be able to survive partitions in the network. But to do that, again, you kind of have to pick between consistency and availability. Both Couch and Mongo go the consistency route, and they use. I'm not actually sure about Couch, but I know that Mongo has like a locking mechanism on their documents that they use to kind of make sure they're consistent before they yield a result. Cassandra, on the other hand, goes with availability. It's not strong consistent. It's highly available. So that's where they tend to diverge a little bit. So yeah, no, good question, Doug.
Right. Thank you.
All right. Anyway, so when you're building an e-commerce site, this is exactly right here what you do not want your customers to ever see. Have them waiting a while. Maybe after a little bit they get that, and a little bit more they get that, and then that and that and that. You want everything to be responsive. You want everything to come back. And again, the idea is that we're going to show you how to do that so that your database is not the bottleneck here. Now, there's something to be said for, writing good, clean code, but a lot of times the database tends to get in the way of developers instead of helping them out. And hopefully, we're going to give you some tools on how to get around, a lot of the pitfalls that can happen of running a large-scale e-commerce site at scale. All right, so I mentioned Spring Data Cassandra. It has some really great features if you're a Java developer. You can manage your connection properties really easily. I already mentioned that it reduces a lot of the boilerplate code. A lot of times when you're writing your own data access layer, you end up writing a lot of the same code that's like specific to, a specific like database or table. And Spring Data kind of gets you around a lot of that. And it has some great, really useful, extensible CRUD methods as well. That let you like save and find things really quickly, even delete. But to be honest, I have a little bit of a love-hate relationship with Spring Data Cassandra. Um, Something like this with count is going to do like a full table scan underneath the hood. And then of course anything with the word all in it, you should be suspicious of. So the idea is that you really want to try to understand what's happening underneath when you're using like a data access framework. And in this particular slide, I had 2 Star Wars memes that I felt were appropriate, and I couldn't decide, so I put them both in here. But essentially, I have helped developers kind of troubleshoot their way through Spring Data Cassandra before, and count and find all are definitely culprits in terms of things that lead to not so great performance. So just something to keep in mind if you're going down that route.
What? Sorry, Aaron, another question.
Sure.
Is there indexing?
There is indexing. Um, it's indexing in Cassandra has a little bit of a checkered past, but the most recent implementation of indexing is actually pretty good. And we actually use it in our cloud database as a service, and it performs quite well. Actually, I'm going to show that a little bit later with an example around vector search as well. So,
Thanks.
yeah. All right, let's have a look at the individual use cases. So there's a lot of pieces that go into building a complete e-commerce website. But we are really just going to kind of focus on these four. So user profile, when users log in, you want to be able to like kind of keep track of them, as well as have things like their address so you can send them packages and whatnot. Users are going to need products and ways to track products so that they can find what they want. They're going to need a shopping cart to add products to. And then ultimately, they want to convert those shopping carts into orders. So those are the four systems that we're going to take a little bit of a look at today, and we'll go into into details on some of these. Yeah, and otherwise too, at the end, I do have the GitHub repo to the complete website stack at the end. So if there's anything specific that I don't cover that you want to go and have a look at, you totally can at the end. All right. Well, a little quick definition of all of these, but the product catalog or product subsystem is really about like category navigation, specific data for the products themselves, as well as pricing. And you'll notice too in that if you look at the complete data model out on GitHub, in that is that the pricing data is actually kept separate from the product data. And you're going to find that a lot of big e-commerce places will do that, especially those that also have like brick and mortar stores, just because the same product can actually have a different price depending on where you are in the world. So that's something to keep in mind as well. And of course, there's a shopping cart. This is pretty simple. You just want something that keeps like metadata about the shopping cart or carts if you want it to be possible for your users to have like multiple carts. That's actually how like shopping lists or wish lists kind of get built too, is that underneath it all, there are carts and they get converted from being wish lists into carts, and that's kind of how those work. And then of course, a lot of times the main thing people think about when they think about what a shopping cart does is it maintains and shows what products are in it. So that's the other part of this that we're going to look at as well. User profile, pretty simple stuff, just information about the user. We're actually in this project we have a single sign-on with Google. I think we built it as an example with both Google and GitHub. Now, obviously, a lot of e-commerce customers say you go to like Walmart or something. Most people who shop at Walmart probably don't have GitHub accounts, but I think it's more there for an example than anything else. But it's certainly something you could do. You see single sign-on a lot too with Facebook. That's one of the more common ones as well. But we actually have a working example with Google in this too, if you wanted to have a look at that. And then the ordering system. Basically, kind of two things on this is that, keep track of, all of the order data, like the products on the order, when it was placed, all the specific order metadata. And then there's also an order history table too that kind of tracks the like the status changes so that, if you wanted to look at, you take a closer look at how your order progressed, you could see when those statuses, were updated. All right. Let's have a look at some data modeling. Now, data modeling with Cassandra is a little bit different, as many of you know. It's the idea is that with Cassandra, you want to build your tables kind of suit your queries, and that has some great examples too, or great benefits too, I should say, where offers like fast reads, offers usually a very simple query model. Because Cassandra does not allow joins actually. And then, kind of the con to that is, yeah, you see a little bit of data duplication, but in the end, that's really not the end of the world. It does lead you to some, like maybe some manual data integrity that you just kind of have to keep tabs on. Doug had a great question before about indexing. In the past, Cassandra indexing has not been great, which has led to a lot of these data modeling techniques. Even with the the newer type of indexing that we have now in Cassandra 5, um, modeling like this and building a query table, instead of having like two separate tables, so a table built to suit each query, is still going to perform better. But again, indexes are one of those things that are more about convenience really than performance. So it kind of comes down to the like individual use case if it's whether it's appropriate or not. But there are some factors that go into that as well. All right. So of course, Cassandra primary keys are really the primary key definition is really the way that kind of sets how each table can be queried. Just to start with some definitions, that partition key, and you can have multiple partition keys, but usually there's just one. But the idea is that when hashed, that partition key tells tells the coordinator node where in the cluster that specific row or specific piece of data is stored. So any good query in Cassandra is going to have that partition key, just so that we can have proper high performance query routing. There's another kind of keys that go along with partition keys, and those are clustering keys. And the idea there is that inside each partition, your clustering key is going to enforce that like on disk sort order, and also provide additional uniqueness within that partition as well. This can come into play too when you look at things like orders for a customer. You might partition it by like customer ID or user ID, and then within each partition, you'll have all the orders listed out. And you might have it sorted by like a timestamp, again, just to kind of have like the most recent orders on top, or however it is that you want to show it. But that's just an idea, and we'll see more examples of this as we go on. The overall data model for these four subsystems sort of looks like this. If you wanted to take it back to like somewhat of an ER diagram, you have users. Users have things like addresses and other metadata. User has a cart and they add products to the cart. Users can check out and create orders. Both carts and orders, kind of contain products. So again, just kind of a high level flow of how these subsystems are all kind of related to each other. So if we look at like what it would take to model out the shopping cart specifically, there are some questions that need to be answered. Like, we need to be able to query a user's active cart. That's assuming they have more than one, or all of the carts if necessary. We need to be able to view all products in a specific cart, as well as add a product to and remove a product from. So when we start talking about these actions and what we need to perform, it really starts to lay out the mold for what queries are going to have to follow. So specifically in the realm of like user carts or cart products, what we're looking at is we have that cart metadata that's stored in like like the user cart table. But we also have products that are inside of each individual cart. And this separation, again, just it lets us do things like, maybe list out, different wish lists or carts that a user might have. And it also helps us keep track of products that are inside of each one of these as well. So if we look at solving the cart product query, for, hey, I have this cart ID and I would like to know what products are all inside of this cart. This table definition is kind of what we would be looking at. So we kind of have, the cart ID as our partition key. So the first primary key listed is the partition key. And then we have like the product timestamp, again, just to kind of keep some semblance of order of like when each product was added to the cart. Maybe you have product ID there for a tiebreaker. There are other ways that you could model this too. I mean, really, if you made product ID a time UUID, then really you wouldn't need product timestamp because then they would be in order by time. But, neither here nor there. Um, and then, of course, one thing that we did too on this table was to add a default time to live or a TTL of what is that? 5,184,000 seconds, which I think comes out to 2 months. And the reason for that, and we're gonna diverge from Cassandra for maybe just a little bit, but I've been a part of troubleshooting some production issues in the past where we have had like a bot attack on the site. And what we'll see happen is like an old shopping cart will suddenly get hundreds, sometimes even thousands of cart ads in the span of just a second or two. And the idea, we think, was that somebody was out there trying to like scrape prices or things like that. Didn't really know for sure, but the idea is that after a little while, we started expiring old carts. It's just an extra surface of attack, and if somebody really wants to come back and buy something 2 months later, they shouldn't have too much of a problem with starting over with a brand new cart. Adding something to a cart and then leaving it for 2 or 3 months with the expectation that it's going to be there when you come back. You may or may not want that to happen, but you don't want them to live out there forever. So that's why we kind of went with the solution of, yeah, let's put a default TTL on everything that gets written to the cart table, just to kind of head that off a little bit. All right. So, hey, we've talked data model on some of these use cases. Let's have a look at the service layer. So, this site actually does have a Swagger spec as well that we have on there. This is one example from it where it just kind of shows the 3 different services that we have out there for the user service. One is used by a like a third party type of login, like I mentioned, Google and GitHub, and there are some other single sign-on options out there as well. There we have one if you just want to be able to get your user data by user ID. And then we've built out another if you want to be able to retrieve that same user ID or same user data by email. So this is where we'll kind of get into the concept of, building tables to address specific queries. So for user profile, we kind of have some, just standard user data, email, name. We have addresses there as a user-defined type. I think I get into that in a little bit. Password is, of course, hashed. You never want to store passwords in the clear in your database. And addresses are a collection. Just that, from my time working in like B2B e-commerce, you'll find that customers will often have multiple addresses. Like when I worked for Grainger, there's we sell a lot of supplies at Grainger for like building maintenance. So we'll have other companies there, and these companies will have like a bill to address and a ship to address, and sometimes there's a couple others, but the ability for users to have multiple addresses is sometimes necessary. And then it's actually stored as like a frozen collection. And the idea with that kind of helps with reading that collection out of the database. And at read time, you get a little bit of a bonus because it's faster. It's a little heavier at write time because a frozen essentially means it'll rewrite the entire collection with every update. But yeah, and again, that's more about like each individual use case. That could be a little different. People don't update their addresses terribly often. Even if they did it once a year, having it frozen, you would still see the benefits from that. Something that's updated a lot is where you kind of lose the benefits of having it be frozen.
So, Aaron, one question.
Sure.
When you mentioned the collection, so if you have to rewrite, I get that there's no update. It's not like this is an Oracle database. It's totally different.
Right.
But yeah, so you're not updating individual rows. So if you have to rewrite it, are you rewriting every customer record?
This is just for the address, actually.
Oh, okay.
But yeah, yeah. So let's say that they had like a build to and a ship to address, and they updated like one of them, maybe the ship to, they had to change the floor number or something. Well, when you did that update, that mutation would then just rewrite the entire collection. So it wouldn't be able to do just that tiny little change in the one address. It would rewrite both of them in that case.
Okay.
That's
So
the only drawback there.
no problem. So just to be totally clear, you
Yeah.
mean rewriting just those two addresses for that one customer, not, all 70 million addresses for all customers.
No, 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 no. Just the one customer. That's right. No, good call out. All right. So I talked a little bit again about the user addresses. In this one, we used a user-defined type. There's no key really necessary for it. It's just think about it in terms of Java, how you could create like an entity class and then have an object of that and add those objects into like an array list or or a set. A set is the other one. Thank you. Wow, I spaced out a little bit there. Anyway, so that's kind of what the address data type itself actually looks like. And then of course we have user by email. So with the way this was set up before, we had user ID as our only primary key. So really, that's how we've restricted the ability for this table to be queried. Um, Now, user by email, that's certainly something that we could have made the partition key in the user table, except that emails kind of, I mean, they can and do change. It's not very often, but it's not something that you want, especially with a big enterprise customer. It's not something that you want to have kind of happen a lot and then have them start over with a new account just because their email changed. So the idea is that we do have that user ID as the main key, and then have this sort of manual index as a one-off. And the idea with this type of approach is that it limits the amount of nodes in the cluster that will be contacted by any given query. So in this case, if you provide an email address, this table here, it's going to see that user email and know which node that data is on, return that user ID. Then you can make one more query and it'll know which node that user data is on by the user ID. So it's kind of a two query system, but traditionally speaking, that works better than having a distributed secondary index on it. To be quite honest, I haven't run the performance numbers on the new indexing strategies that we have to know if they're faster than the traditional manual index approach. But I just know that a lot of times those indexes have trouble with when they're put on columns that have a high degree of cardinality. So something like an email address would be very, very unique. That may not perform as well. So the manual index on something like that may be the way to go. Um, just a thought.
Okay, so Aaron, just to clarify,
Sure.
I think I've got what you're saying. The user table is indexed by the user ID. You have fast access, immediate access to a record off of that. And the user by email is indexed off the email address, so you can instantly get that record.
That's right.
Okay. Got it. Thanks.
Yeah. And then here I just have a little example of kind of what that query would look like. So here's how we'd query user by email, and it would return that user ID that you then use to go ahead and pull back that full user record. Just to clarify on that.
So I think I recognize that type of number. Is that called a GUID, Global Unique Identifier?
Yeah, yeah. So GUID is more of a Microsoft word, I think, but usually GUIDs are synonymous with like a UUID, which is again short for like a type 4 UUID. There are actually two types of UUIDs that Cassandra supports, and that's a type 1 or a time UUID, excuse me, time UUID, or a type 4, which is not time-based, but yeah, generally considered to be unique and collision-free. Again, kind of like a GUID is. The way you can tell is that I think it's this third octet. If that first number is a 4, then you'll have like a type 4. Otherwise, for a time UUID, there's a number 1 right there. But
Okay. Well, thank you for mentioning that. Yeah, I spent a
yeah.
number of years working at the bank, and we weren't doing any Microsoft stuff, but we all use that term GUID. So thank
Oh,
you for
sure,
clarifying
sure.
that. It's
Yeah.
UUID is the industry standard. I take it.
Yep. Yep.
Okay.
And I was going to say, before I was in the Java Cassandra world, I'd done a lot of .NET development, Microsoft .NET, and yeah, you're right. That's where we called them GUIDs as well. So yeah, that's a little bit of background there. All right, and ultimately that comes down to this get user by email service. So this is where I talked about here's that find by email, and then once you get it, now you can do the find by ID on here. So there's an extra step in there, but again, this is kind of how you would use that manual index in practice. All right. Like I said, we're not going to dig into streaming too much, but the site actually does use Apache Pulsar to have different stages of the order lifespan, I guess, to go one on each topic. So the idea is that we want to be able to place a user's order and allow all these different business functions on the order, and then also be able to track that status timeline. So really what this looked like was that we had these 4 topics inside of Pulsar. Note that you could totally do this with Kafka as well too. But we had topics for like, when you place an order, it's pending. Once it gets picked from the warehouse, it becomes picked. Once the shipping department puts it in a box and sends it down the conveyor, it's shipped. And then when a driver drops it off at your house, that's when it's complete. I actually do have an order processor project that goes along with this too, that can actually move an order, through those different topics. But that's not something I was going to focus too much on today. So then, of course, vector search has really kind of gained in popularity over the last few years. Vector databases are, again, kind of that key data store component that's behind generative AI, and specifically like RAG-based applications or retrieval augmented generation. This project actually uses it for product recommendations. So the idea is that I've just done a simple like Hugging Face. I forget which exact Hugging Face model I used, but it's just it has 384 dimensions. I took the name of each product and generated a vector embedding, so those are stored. And then the idea is when you add a product to your cart, it looks it up in this product vectors table, takes the product vector, and then does a ANN or approximate nearest neighbor search to find like products. So that's where you add like one kind of t-shirt to your cart, and it'll suggest a different t-shirt that you might not have. So this is, in a sense, kind of how vector search works, and really how you could use it as well. And this is actually part of the demo. You'll see this happen when I go ahead and add a product onto the cart.
So quick question on that one. Those
Oh,
numbers
sure.
in the product vector that start with -0 or 0 point, what do those mean?
Yeah. So those are the individual yeah, that array basically makes up the vector embedding. And the embeddings are actually when you run it's not an LLM, it's a sentence transformer. So when you run like a string through a sentence transformer, it can actually embed that, which is a floating point array representation of what that string was. And the idea is that, I mean, this is, ultimately when it comes down to it, anytime you're doing any sort of like generative AI or chatbot search, this is what's happening under the hood is that like your string that you're typing in is getting a vector embedding created for it, and then it's going through this like vector calculus to do like a cosine based ANN of like what pieces of data are the closest match to that string that was put in. So that's ultimately what that is. So those individual floating point values on their own, it's it's really hard to tell what each one of them means, without having that without having the model that they are generated with as well.
Okay, so that last one, for example, those numbers would represent the string go away annotation t-shirt. Is that right?
That's right.
Okay, gotcha.
That's right.
Thanks.
Yep. All right. So I actually have the get promotion product code here. I'm just noticing we're kind of getting down to it on time. Um, but essentially what this is doing is it's taking that product ID and it's pulling back that product's vector, and it's using that vector to get like to do like a limit 8 of a select. Now, the reason that I had it do a limit 8, and that's because I kind of understand a little bit about the business rules around the data, um, is that a lot of the products that I have in this site are t-shirts, so you know Doug made a good point of calling out the one that says go away annotation t-shirt. That one is available in like small, medium, large, extra large, and I think like 2XL as well. And what you're going to see is if I were to take that product's vector and search for it, is that the top matches would all be the other sizes, which really, if I have a large t-shirt, a small t-shirt that says the same thing isn't going to do me a lot of good. So this is where I want to make sure I get back, because I know that I don't have any more than 8 sizes of any t-shirt. So if I ask for 8, I know I'm going to get at least one that's different. And then the idea is that I'm iterating through them, trying to find one that has a different product group, because I know the first one that comes back that has a different product group is not going to say the same thing. It's going to be a completely different t-shirt. So again, that's just some of the this is like a business rules implementation, again, just to kind of make sure that we're getting back useful data to the customer. And like I said, you'll see this in action in just a little bit here. All right, so that's basically time for the demo. I have 9 minutes and I shouldn't need all that time, so that's good. We'll just do a few basic website operations. I'm not actually going to place an order just because I don't have a Pulsar backend tied into this right now. And you'll see this again, but my GitHub repo that has all this code is out here. The only reason it has the word prototype on there is I named it prototype when I started to implement vector search. I just wanted to be sure that I had a way to like roll back and not actually like mess up or taint the original repository. So that's a result of the vector search implementation. But I suppose at this point it works well enough. I could probably merge that back. Anyway, let's go ahead and let me get this started here. All right. So now I should be able to go, yeah, let's go localhost 3000. And okay, it pops up. And I actually have this running from an npm start for the front end. And then I have the back end actually running out of my my IDE. But this is essentially what the site looks like. If I go ahead and do a login, you'll see I have an option for my Google account here. Come on. Ah, okay, I swear this worked yesterday.
This is one of the Murphy's Law's corollaries about demos.
Oh, I know, right? Oh, let's see. Am I getting no, no, I don't see any errors coming back. Oh man. All right. Let me try one more time here. Yeah, Google. Ah, all right. There must be
What
something.
happens? I'm going to say, what would happen if you hit sign up? Might go through a different path?
It would go through a different path. Yeah, I suppose I. Hey, wait a second. No, it shouldn't be showing that. See, because now if I hit. Ugh. All right. Well, we're gonna have to skip everything related to to signing in, I guess. So let's go ahead and have a look at t-shirts. So this is an example of like kind of the product category navigation, how that all shows up. Um, these are the individual shirts that I've put in there with you know the different products that are available. If I go ahead and click on like the Apache Cassandra 3 contributor shirt, see that it comes up. You know, I can say that I want an extra large. I actually have different pricing in here for like, you know, if you go 2x or 3x, you notice the price increases a couple of bucks. So there, you know, there's that option as well. But I'll go back to extra large. Let's say add to cart. It should let me do it. Oh, there we go. So I added to cart. And then this is the product recommendation feature that I told you. So it took that vector by from the Cassandra 3 shirt and was able to bring back the go away or replace you with a Spring Boot annotation shirt. Um, I didn't put in a way to actually go directly to that, you know, so I could go here and I could add that in. And it would it suggests a different you know annotation shirt, but that's okay. Let's have a look at the cart. Now, without signing in, it should give me a generic user ID. So I still should be, oh, yeah, here we go. Oh, and I had I had another product sitting in there. But yeah. So, you know, as you can see, these are you know, kind of the front end with how that all works together. You know, one thing too, and I suppose I could show in the closing minutes here would be, oh, let's see here. All right. So I can say use e-commerce. And if I do a describe tables, you know, yep, you can see that, you know, we have all of these available. I can do a from cart products. Oh, I wonder why that doesn't, huh.
So the command prompt that you're at is inside an app, right?
Yeah, this is actually inside the database. Yes.
Okay.
Oh, here we go. So, you know, Doug, you had a question too about like the individual or like the vector embeddings. Well, here you can see the full 384 uh, item float array that that kind of matches up with the Apache Cassandra 3 contributor shirt. I actually have a you know, again, like another, you know, sidecar loader for this that that would go through the products and actually generate these embeddings for each one as well. So that's kind of how the vector search is driven there. Um, so yeah, that is pretty much it, I suppose. Oh, right. I finished with some tips. Not to be like, you know, about like general web tips, but you know, when you're working with money or currency, it's always important to remember you don't want to use a floating point type because they're inherently inaccurate. So in terms of Java, you know, I have a recommendation on there for big decimal. The currency type inside of Cassandra itself is decimal, like that. If you want to see what happens with floating point accuracy, you can actually check out this site. It's you know, HTTPS 0.3 and then I think it's 15 zeros 4.com. And that actually kind of explains what happens when 0.1 and 0.2 are added together, is that yes, you do in fact get this as a result with a, I think it's with a 32-bit floating point type. So anyway, for currency, don't use floating point types. Always use like a special, like a decimal or a big decimal type.
That was a huge thing at the bank. I'll never forget the day I ran a reconciliation of 74 million customers, and they said, "Yeah, that's pretty good, except you're off by 1 penny, so it's total a fail." And it was this
Yeah.
issue. Yeah. Like,
Yeah, it has to do with the fact that those floating point types are really binaries under the hood. And what it's trying to do at a certain level is add fractions of like two's complement numbers, and that's where it kind of gets confused and it has extra bits on the end. But anyway, I recommend reading that site. It kind of explains it all. All right, make sure you're using TLS certificates. You notice from my example, well, maybe you didn't notice, but I did have HTTP. Make sure you're securing with a TLS certificate. And really, I should get around to doing that with this project as well. Um, Tax calculation, do not attempt. There are lots of tax software packages out there, and you absolutely should use one. Do not attempt to write your own. Don't just go, oh, hey, in my state it's 8% or 815 or whatever, and just do that because it doesn't take into account like special county or city taxes. So just, yeah, um, don't do this on your own, is going to be my warning there. All right. And here's just the, oh, wow, we're wrapping up like right on the minute here, pretty much. Oh, actually, I have a couple minutes. Okay. I have one clock that's not terribly accurate here, but that's okay. I have my GitHub repo kind of at the top here. Again, all the code that you've seen in this presentation will be found in that repo. Sohail is actually going to get the video of this presentation up on our Planet Cassandra YouTube channel. So you'll find that out there as well. Oh, we also have a Discord site as well if you like Discord. I have a link in here for Pulsar if anybody's interested in Pulsar as a messaging system or event queue. Hey, have a look at it. It's a great project. Of course, there's the Apache Cassandra project as well, which is what we all hope you end up looking at. And then as far as like other videos and instructions out there, I mentioned the Planet Cassandra YouTube channel, but we also have the DataStax Developers YouTube channel where the original videos for the workshops that we built from this project are out there, as with years of other videos showing how to use Cassandra and yeah, help you learn about using Cassandra and building apps on top of it. Um, there's going to be a lot of material lately about our Gen AI platform known as Langflow, but there's plenty of good material out there as well on what we talked about today. So, I mean, that's really about it. Just yeah, thanks everyone for coming out. I'll leave this page up a little longer just in case anybody wants to have a look or screenshot those addresses. And in the last couple of minutes here, I'll take some questions. I know Doug kind of asked his along the way, but if anybody else has any, I'm happy to answer.
if nobody else has one, I've got another one for you.
Oh, go right ahead.
We didn't talk too much about normalization and denormalization, and I have a feeling that that's a pretty important topic for Cassandra database. And I sort of got it a little bit when we were talking about, the organization, the data model earlier.
Sure.
How do you decide, what things get merged in? If you come from like an Oracle background, you're going to, Oracle folks normalize everything to
Right.
the nth degree, whatever. But I don't think you do that here in Cassandra, do you?
No, that's right. We do take a little bit of an approach to denormalization. I think I did have it on a slide in there, in that in some of these cases when you're modeling for specific types of queries, that sometimes you might end up with duplicate data, and that's okay. Again, there are some extra steps when you do want to keep that in sync, but we have some mechanisms to kind of improve the atomicity of that as well. But yeah, denormalization is usually the name of the game there. And it's a good mention about Oracle and other relational databases as well. Is denormalization actually helps there too. Now that's something they don't like to talk about. But in terms of performance, it actually, you will find that that does happen occasionally in the relational world.
Yeah, I think that's a really good point. I have a feeling that if you take a third normal form database from Oracle and put it against Cassandra, Cassandra is going to be high availability, like you mentioned before, and outperform it by a long shot in certain types of situations.
Yeah, and that's the key there, and that yeah, certain types of situations. It's funny is that when I was at Target, the tech lead of the Oracle team, was kind of ribbing me once, and he's like, "Oh, Aaron, you have to do all this just to get 40,000 IOPS." He's like, "I can get 40,000 IOPS just by turning on Oracle," and I'm like, "Yeah." But it costs you $11 million to do that, and I can do that for free. So don't get me wrong, Oracle's a great solution, but I hope you're wealthy.
Yeah. I got one more for you since you mentioned cloud before. You guys,
Sure.
if people go and run stuff in GCP or Azure or AWS, is Cassandra on those platforms? I would imagine it is, right?
Yes. Yes. We actually offer a database as a service called Astra DB, and Astra DB runs in all three of those clouds. Um, Additionally, if you search in the marketplaces of all of those clouds, you'll find our enterprise offerings like DataStax Enterprise, and I think HCD Hyperconverged Database is in there as well. But I'm pretty sure that all of them have their own, like when there's a new release of like open source Cassandra, they kind of have that as a product there that you can pick and that you can use. I know Amazon specifically has Amazon Key Spaces, which really is like Amazon Dynamo under the hood, but it has like a Cassandra like API on top of it. It's not 100% compatible, but it's okay. So, most of the customers we work with will actually like spin up their own instances and install Cassandra on it themselves. That's actually like Netflix's approach as well too. So,
Okay. And if you've got 30 seconds left, I got one more for you. It's
sure.
on your screen. You mentioned Pulsar and Kafka before. Do you have opinions on which way to go there?
You know, um, I've never worked in the I don't have a lot of direct production experience with messaging and event processing with those two technologies. I can tell you that the Kafka space is huge. I think Kafka has like 85% of the market or something like that. Um, the idea with Pulsar and how it came about was that they were trying to build like a cloud native version of Kafka. Well, I don't know if that's entirely true, but they wanted it to be more cloud native than what Kafka offered. So the idea where you have like in Cassandra where it's like geographically region aware or it's data center aware. Well, they added that to Pulsar. That was kind of the idea that was built into that. So yeah, Kafka is it's definitely great tech. I can tell you that I did hear rumblings from the Kafka team while I was at Target about having issues doing like multi data center synchronization. So I do know that was like a pain point then. And Pulsar may solve that. So yeah, that's all I'll say on that.
Okay. Good info. Thank you.
Yeah. All right, with nothing else, hey, thanks everyone for coming out. And the recording should be available on the Planet Cassandra YouTube channel. So thanks everyone, and have a great rest of your day or night.